Hello, everyone, and welcome back to another MAT 142 concept session. Today, we're going to be talking about experimental and theoretical probabilities. My name is Nick, and I work with the ASU Tutoring Center, so let's go ahead and get started. When first talking about and looking at experimental and theoretical probabilities, it's really important to understand the differences between the two. Now, with theoretical, that's kind of like what we've been working on in the past. So think of that more as like the expected probability, right? So even just kind of looking at our example question here, they want us to calculate the experimental and theoretical probabilities of landing on gray. If we think about the theoretical probability, that's kind of what we've been working on, right? So that goes back to like our fractional probabilities, right? So when computing the theoretical probability of landing on gray, our denominator is the total amount of outcomes that could come from spinning the spinner, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 different possibilities. And then they want us to find the probability of landing on gray. So we'll count up the total amount of gray spots, which is just 1 and then 2. So our theoretical probability of landing on gray is actually just 0.2, 20%, right? Now for experimental, in order to compute an experimental probability, you are required to be given data, right? So that's what this is for us to calculate our experimental probability. And it is kind of similar actually to how you calculate the theoretical probability. You're just using different data points, right? So in order to calculate experimental probability here, what you have to do is add up the total amount of trials that you ran. So in this case, 409 plus 388 plus 203 is equal to 1,000. And that's going to be your denominator. Now for your numerator, you're just going to take the number that's in the outcome that you're looking for. So in this case, our outcome is gray. So we're going to put 388 in the numerator. And then this is going to give us our experimental probability of 0.388. So just to recap, again, theoretical probability does not involve any kind of experimental simulation data at all, right? That is just thinking about the problem and then coming up with what the probability should be, right, of landing on it. And then experimental probability is when you're given data and you're actually kind of doing analysis, right, and looking to see what was the probability of landing on an outcome given this kind of experiment that we've been running. Really, the only other thing to really point out and think about is in order to get your experimental probability close to your theoretical, right? Because in theory, right, and that's why it's called a theoretical probability, you should have a 0.2 chance of landing on gray. Like we determined that, right? But a lot of times, like in the real world, that doesn't actually happen, right? But a way to get your experimental probability closer to your theoretical probability is to increase the amount of trials that you're running, right? So say instead of doing 1,000, we did 2,000 trials. Most likely this 0.388 would have probably gone down a little bit, right? So it's just important to kind of keep those things in mind. But other than that, that's all I have for you. So if you have any other questions, go ahead and check out that link on your screen. That'll direct you to our website that lists out all the free tutoring services that you have available from being an ASU student. If you're looking for just generic one-on-one tutoring, you can also go to that same site and type in your course that you're looking for help in. And the system will actually spit out a list of tutors that can tutor that specific course, and it'll also display their schedules as well. But other than that, that's all I have for you. So I hope you have a great rest of your day and good luck in your course.